Okay, yeah, got something I've just purchased recently on eBay. It's an old Roberts PS9 battery eliminator. It's pretty, I mean obviously it's got a small transformer, nothing too hefty in that, it's quite light. Got some pretty ropey mains cable on it, I'm going to need to change that. And I've got the old plug without the plastic bits. The new plug should be like this with the plastic insulators. Doesn't really make a lot of difference, but it's supposed to stop you touching your fingers in if you grab the plug like that as you're taking it out. If you've got tiny fingers, there's a very remote chance you could get a shock. So I thought we'd have a look over this and give it a few tests. So first of all, let's have a look to see what size fuse it's got in it. I would expect it to have a 3 amp max. Get away with an amp on it probably. It's got a 10 amp fuse in it, look. Oh my god. Yeah, I don't think it's going to need a 10 amp fuse, do you? It's only 400 milliamps output. Let's grab a 3 amp a minute. Let's say 1 amp will probably be okay, but let's check the wiring. Wires seem to be in the right place. Blue is in the neutral. It looks like it's been clamped down on the live wire, but someone's actually even soldered the ends of the wire. Ooh. Why on earth have they put a 10 amp fuse in it though? Unless it's blowing. We'll check that in a minute before we switch it on. Unless it's blowing 3 amp fuses. I don't know when I last seen a 10 amp fuse. Right, let's put that back in. As I say, I'm going to change the mains lead on this and put a new plug on. Might even see if I can just get a moulded one. Let's see if that fuse is okay first. No point putting it in the box if it's blown. Just get the multimeter, pop it on buzzer. It should. Let's make sure it works. He's good. Let's get that back out of the way. Right, we'll say it's only a 2-pin wire, so I can't test between the earth pin and the others because there's going to be no connection because that's not connected. So all I want to do really is just check the resistance between the 2 pins. Make sure we haven't got a dead short here. And now there's virtually, it's very high resistance. 560k. Yeah, it's fine. Really dirty plug. So let's switch it on to voltage. What I'm going to do, I'm going to plug it into my variable power supply here. Let's just zoom you out a bit so you can see what I'm up to. So I'm going to plug it in down here. You'll see stuck in underneath my bench. Is this beastie? So let's just wind it right back. Power on. Excuse me, the cable's hanging down over. Just going to plug that in. We know it's safe. Let's wind it up. On the voltage. What I'm going to do is measure the voltage on the output pin here. Can't see that. Yeah, measure the voltage on the end of this one in a minute. So let's wind it up. There's no ampage showing at all, so there's nothing. Let's go right up to 200 and 239, that's good enough. Let's put it back over to here. I've not got it open, so I've not got any problems. It's centre pin negative, apparently. So we'll have a look at the meter there. Nine volts, which is what it should be. Output voltage 9 volts. So it's working, but there is some other issues that I've found. Obviously we've got the problem with the mains lead not being brilliant. The other problem is this shroud here should screw on, but looks like threads are gone. There's some pretty bad wiring there as well. So I'm either going to have to put another plug on it or just replace this back one. I think I'll replace the back one because it has quite a long shaft on that. Anyway, let's have a look inside. I'll assume it's the 4 feet come undone, because I'm going to use this for quick testing, save me messing about my bench supply. Well, I'll initially test it with my bench supply with current limiting, and then this afterwards. So a little look inside then. So a pretty basic power supply by the looks of it. Live and neutral in transformer. 100 milliamp anti-surge fuse, couple load capacitors, bridge rectifier, a lock fit transistor, just a little trimmer. I'll assume that's to get the voltage right. So that should be easy enough. I think that's a silver plated contact actually. Yeah, there's some pretty rough wiring on that. So yeah, pretty standard. That's obviously the reservoir capacitor. It's 680 microfarad. That's 150 microfarad. So what we'll probably do is whip those out, get them changed. Yeah, let's get that done a minute. Let's see if I can find another mains. Okay, I've got some new mains cables already pre-wired. New plug, never been used. They came off of some lighting, some lights that I had. Again, 400 milliamps. I don't need a hefty cable with it. I'm going to probably change that grommet for a slightly smaller one, because this is a slightly smaller diameter than this, but this is perfectly capable of running fair ampage. It's, what does it say? 0.75 mil. Yeah, 0.75 mil squared. I don't know what this thing is. Probably exactly the same. Right. So we need a new back for that. Rewired. It's got the red going to there. Right, let's get these nuts off. Oh, that was a different size. There's a little bit of wood in there as well, look. Bit of wood on top of the heatsink, top of the transformer. Dear oh dear. I dropped a foot and screw now. Screw that. There we go. I'll stick these in a pot and that. So I'll start losing stuff else. Well, it didn't look like that one needed to come out, or that one really, but I do need to get that one out because I want to put a new cable in. That trace is actually lifted off the board there. So what I think I'll do with that is I'll put a bracing wire across and yeah, I'll put a bracing wire across that. And I think I'll epoxy it to the board. Just make sure it doesn't move again. So I don't want the mains cable moving. Right, what I'm going to do now, I'm going to put my solder sucker on and I'm going to remove the two capacitors and this mains cable, so bear with me. It's a bit noisy. Okay, well I've got the two capacitors done. So I'm just in the process of popping the mains cable in. And I've got I tinned the ends because every time I tried putting it through it went haywire, so let's give these a go now. Come on, hitch all this. Okay, let's see if I've got a couple of decent capacitors. That's a nice chunky one there. That'll do nicely just to brace that one across. Not that it looks like there's anything wrong with it now, it's oh. that should give it a nice brace. Let's just snip that end off. So we can touch that one in. There we go. I think I'll do the same on the neutral wire as well. Just give it an extra bit of support. It doesn't look like these traces are that robust. There's a poor joint on there. There we go. Let's give that a little touch up. There, it's a bit happier with that. Right. So, just got to put it back together now. Before we do that, we'll just check these capacitors, see whether that was a waste of time. I don't know what sort of age it was when these were made, these power supplies. Anyway, let's pop the ESR meter on it and have a look. That's quite a high ESR. It's dropped a little bit now on second try, but it should be 680, it's 800, this one's a 150. It's been 192 again with high ESR, so yeah, definitely was worth changing those two. So I'll put it back together and join me in a minute when it's all sorted. Well, I nearly forgot me little plug. So I've cleaned that up, the end of that up with a bit of Brasso. I don't know if it's silver or not, it may well be, so I get told off if I try cleaning solder with abrasives, which Brasso is. It's better than sandpaper. Naughty. Anyway. So I'm redoing this joint, it was pretty bad. Trying not to lose any strands here. Cut it back quite a way. It's a screened wire, this. It's not just a 2 core, it's a 1 core and an earth. So I'll try and tin that in a minute. Just stops it unravelling if you tin it. It's a pretty old wire as well, so it's going to get a blob of flux. Seems to have taken well. Good news. Now, even though the center pin is negative on this, the wire that we're using is the red, which again, who knows. So, I mean, that ideally needs to go through that hole, but it's going to be too big, I think. But I need to clamp the cable on there. So what I'm going to do, let's see if I can get some solder inside there. So, some fresh solder in there. Actually got a bit of solder in there as well, which isn't good. I don't really want that. Just wick that out a minute. Yeah, I've got a bit of solder in the little strain relief here. There we go. That's better. Strain relief's not brilliant. It's not really right for the cable, but yeah, that'll go on there. Won't put it on quite yet because it's a bit hot. So yeah, that's another job done. I don't know if all of that was out of camera. So back together it goes. Okay, well, it's all back together apart from the case, the outer case. So I'm just going to wind it up and see where we are. So it's doing 9.1 volts at 240 volts, same as it was before. If you can see that there. So 9.18 volts, 118. I'm assuming the potentiometer there adjusts it, but I don't know whether that would pull itself down. We can tweak it back to dead on 9. Yeah. So I took it back to 9.000008. That's good enough. So let's just get it back together, and that's another job done. So nice new lead, new plug. Rewired the plug on this end with a new little backing piece. Sort this grommet out. So I think what I'm going to do with this one is I'm going to pop a cable tie on there, just so as if it did pull. Saying that it can't pull out, can it? Because no, it's fine. Ignore that. It's got a whacking great cable clamp inside, so it ain't going anywhere. Right, just screw the feet on. There we are. One finished Robert supply, 9 volt with a new plug, all sorted. It's again only a quick video, but if you liked it, give me a thumbs up, subscribe, and check out my website and my Patreon page. Catch you again soon.